For number 1, it's asking how far horizontally is our fish going to fall? And number 2 wants to know the vertical and horizontal components of velocity when that fish hits the water. So starting off, we have a pelican who's flying at 5 meters per second, 5.4 meters above the water, and in his mouth he has a fish. He's going to drop this fish. And when the fish falls, it's going to have a horizontal component, which is going to be the same as velocity, as well as a vertical component. So number 1 asks, how far is it going to travel before it hits the water? And number 2 wants to take velocity of this fish, because it's going to be falling with a vector similar to this. What is the x component of that velocity and the y component of that velocity? So we're actually going to be using kinematic equations as well as vectors together. So to start off, we need to find how long this fish is going to take to hit the water. So we need to look only in the y-axis and solve for the time it's going to take the fish to hit the water. So I'm going to use these two equations. I'll start off with this one. Final velocity is actually what we're solving for. And even though the fish is moving horizontally, it's not moving up or down at all starting off. So initially it has a velocity in the y component of 0. So 0 squared plus 2. The only acceleration rate is gravity. And then this would be change in y. Well, a y initial would be 5.4. Y final would be 0. So y final minus y initial is just going to be negative 5.4. When we plug those in the calculator, 2 times negative 9.8 times negative 5.4, we get positive 105.95. And this is equal to velocity final squared. Let's take the square root of both. And the final velocity, the moment the fish hits the water, is going to be negative 10.29 meters per second. It's negative because it's traveling down. So now let's take this and we'll plug it into our second equation up here. Negative 10.29 is our final velocity. Our initial velocity in the y-axis was 0 minus 9.81 t. Divide both sides by 981. And now we get our t by itself. And then t equals 1.05 seconds. So that's the time it takes the fish to fall from the pelican's mouth to the water in the y-axis. Now we're going to take this initial velocity and we're going to plug t in for it. So now I'm going to use this equation. xf equals xi plus bt. Now remember, this equation only works if velocity is constant. But in our problem, it never says that the velocity changes, so we're good to go there. So xf is what we're going to solve for. Our initial position is just 0 since we're starting our problem here, plus our velocity, which is 5, times our time, which we just solved for, 1.05. So we plug and chug. The answer to number 1, xf, it's going to be 5.25 meters. That's to say, when the fish gets dropped out of the pelican's mouth, it's going to travel 5.25 meters horizontally before it hits the water. So it's actually going to be traveling more in a path like this as our vector. Now, what number 2 is asking, it wants to know the vertical and horizontal components of velocity. Well, we know that this is the vector. We already know the horizontal component is 5.0. So how are we going to find that? Well, we already did. We've solved for the final velocity right here. This was the answer to the y component, and this is the answer to the x component. So let's write them in a different way. Let's say final velocity sub x would be equal to 5.0 meters per second, and final velocity y would be equal to negative 10.29 meters per second. And the problem doesn't ask for it, but if we wanted to solve for the final velocity, we could just use Pythag. 5 squared plus negative 10.29 squared would equal this magnitude squared. Okay, number 3 is the stunt dummy problem. We have a stunt dummy who's going to jump out of an airplane that's moving 22.5 meters per second in the horizontal direction. The stunt dummy and the plane are 10 meters off the ground. The question's looking for what is the instantaneous velocity the moment the stunt dummy strikes the water. So to do this, we need to find the vertical velocity the moment it hits the ground. So let's solve for that first. We're only looking in the y-axis. So Vf squared is his final velocity the moment he hits it, equals V initial squared plus 2a change in y. Well, so Vf squared equals, this is 0, because even though he's moving 22.5 meters per second in the horizontal direction, he's not moving up and down at all, so he starts at rest initially in the y-axis. So 0 squared plus 2. The only acceleration it's acting on would be gravity. And then change in y would be as y final minus y initial. So this would be 0 meters minus the 10 meters where he starts. So this would be negative 10. When we plug this into a calculator, 2 times negative 9.81 times negative 10, we get Vs squared equals 196.2. Take the square root of both of these, and V final equals negative 14 meters per second. And this is once again in the y-axis. So our stunt dummy is actually going to take a path similar to this. We have the x component, which is 22.5 meters per second, and now we have the y component, which is negative 14 meters per second. To find instantaneous velocity, we just need to use Pythag now. And we'll take this squared plus this squared to get the resultant vector. So, negative 14 squared plus 22.5 squared equals c squared. And, let's see, plug this in real quick. 702.44 equals c squared. Square root of both. And our resultant magnitude is equal to 26.5 meters per second. Now, since this is a vector, it has magnitude and direction, so we also need to find the direction. So let's use this angle right here as theta, and we now know all three sides of our triangle. We know this is 22.5, this is negative 14, and this is 26.5. So you can use any inverse function you would like. I'm going to use the sine inverse. Theta equals sine inverse opposite, which would be this leg right here, which is negative 14, over hypotenuse is what we actually just solved for, 26.5. And our theta will be 31.89 degrees below horizontal. And that's to say, the instant that our stunt dummy strikes the ground, he'll be moving 26.5 meters per second at 31.89 degrees below the horizontal. Okay, number 4 is our cat versus our mouse problem. We have a cat who's chasing a mouse on a table that's 1 meter high. Just as he's about to get the mouse at the end of the table, the mouse jumps into the air, and the cat goes flying off the table with a velocity of 5.0 meters per second in the horizontal plane. The question's asking, where is this cat going to land at? How far from the table is the question? So to do this, we have about 3 different steps we need to do. First, we're going to solve how fast the cat's going to be moving in the y-axis the moment it strikes the ground. They're going to plug that in to find out how long it took the cat to get to the ground. And once we find that time, we'll plug in 5.0 meters per second to find out how far he traveled in that x-axis. So here's our first equation, and this is in the y-axis, just so we make sure we don't get confused. Vf squared equals Vi squared plus 2a change in y. Well, we're solving for the final velocity. Remember, this is in the y-axis. Even though he's moving 5 meters per second across the table, he's not going up and down at all. So his initial velocity for y-axis is just going to be 0 plus 2. The only acceleration will be gravity. And change in y is y final, which is 0 meters, and y initial, which is 1 meter. So it's y final minus initial, will be negative 1. And when we plug this in, we get Vs squared is equal to 19.62. Let's take the square root of that. And the final velocity equals 4.43 meters per second. Now, since our cat will be traveling down to the ground, we'll make this negative. Now, we're going to plug this into this equation. V final equals V initial plus AT. And that's going to solve for our time. So, come up here. Negative 4.43 equals 0 minus 9.81 t. The reason it's minus is because acceleration is gravity, which is negative. This is negligent, minus, or divide by negative 9.81 each way. And the time it takes the cat to go from the 1 meter table to the ground turns out to be 0.45 seconds. Okay? Now, we're gonna use time. We were using it in the y-axis. Now we're just going to use it in the x-axis. Time will be the same either way you look at it. So now we're gonna think more about the x-axis. I'll change colors here. Since we have a velocity, the cat isn't going to accelerate or decelerate in the x-axis. It's going to be moving 5 meters per second the entire time. So we can use this equation. xf equals xi plus vt. And we want to know how far the cat goes in that 0.45 seconds. So the xf is what we're solving for. So it equals, we're gonna say he starts from 0. The edge of the table is where we're starting our coordinate plane. So it'll be 0 plus the 5.0 times our time we just solved for right here. So 0.45. And xf, the answer to the problem, will be 2.25 meters. And this is from table.